Okay, we're jumping now to chapter 11 and looking at volume of these prisms and cylinders is the first one we'll look at. So volume, is different than surface area. Volume is the measure of the amount of space needed to fill a solid. So we're actually going to be looking at three directions now. And here's one to consider. How many cubic units do you see in each direction of this rectangular prism? So if we actually, let's count, there's a block, 2, 3, 4 blocks going this direction, which we could call length. And then let's go this direction. Looks like 1, 2, we can call that width. And then we have to also go height. So 3 different ways we're looking at now. 1, 2, 3 up that direction. How many cubic units do you see? So I see 3 and 4 and 2. And then how many total cubes are in this rectangular prism? Take a second and look at that and calculate what you think. Okay. All right. Did you decide there were 24? Let me put 24 right here. There are 24. So you could count this front layer, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which is the same as 3 times 4. And there are 2 layers of that, since that says 2 right there. So really what we can do is multiply the length times the width times the height, whichever one you called those. And that answer tells us how many cubic units are in a prism. All right, let's try this out then. Volume. To find the volume of a prism, we need the base, and we multiply that by the height. So remember, with a prism, there's a matching base at the top and the bottom. They're parallel, and they're exactly the same shape, size, surface area, everything should be exactly the same. So when I look like at this one, what 2 sides are matching and parallel? Well, here's a triangle right here. And then on the other end is the parallel triangle. This is a triangular prism. And to find the area of it, we would need to know the area of the base, one of those triangles. And then we would multiply that by the height, which is that distance from one base to the other. Okay, let's look at one like this. So this one has several different sides that we could call the base. And that just works out with a rectangular prism. We could call this end a base, and then the other end a base. We could do the top and the bottom as the bases. So they've got a little arrow here. They want us to call that the base. But honestly, that does not have to be the base on a rectangular prism. You can pick which 2 parallel matching sides are the base. So this is area of base. And you guys already know the height. I'm sure you know both of those already, that the big B is the base, area of the base, and the H is the height. Okay, let's try one. We've got a rectangular prism. So you've got to decide, I'm going to put here base times height. You decide what 2 sides you want to be the base, and you've got to pick 2 that are parallel. So I think I'm going to take the bottom, I'm going to call that one base, and then parallel to that, the top, I'll call that my second base. So the area of the base is, and for a rectangle or a square, we do base times height. Remember, different B's. Capital B is the base of that figure. It's a 2-dimensional shape. And then this B is used just for this rectangle. So to find the area of that rectangle, 5 times 7, those 2 sides. That means the base of this is 35 centimeters squared. Okay, now we go up here to this volume of the prism, and we know this capital B is 35, and we know the height is 4. So we're going to put those 2 together now. Ultimately, we multiplied all three sides together, right? 35 times 4 is 140. Now, this is a little bit different. Centimeters, we've been putting squared on there for so long, but we just switched to three-dimensional. So now you've really got to put 140 centimeters cubed, three directions. Okay, let's do another one together and then I'll let you try. This is a triangular prism. I know that because here's a triangle, right? And then on the other side of it is the parallel matching triangle. So triangular prism. To find base times height, that'll be the whole volume. But to do that, first I need to know what's the area of the base, which we just said is a triangle. Triangle is 1/2 the base times the height. And here we've got a little problem. Here's our triangle. I'm just going to shade it in a little bit. So I'm looking at, I need this base area for just this triangle. And I see that the height is 5. They put a little right angle thing there. So I can say height, but they didn't give me the base measurement, did they? They told us that the hypotenuse of this triangle is 13, but they didn't tell us that side. So you know what we're going to have to do? Pythagorean theorem. Okay, it would be a squared plus b squared equals the hypotenuse squared. Be real careful that you get your numbers in the right spot. 13 is the hypotenuse. He's got to be all by himself. Okay, so we've got 25 plus b squared equals 169. Let's subtract 25 from both sides. And that is 137. Did I do that right? Oh, it's 169. I did not do that right. 169 minus 25. Man, you guys might want to do this on your own. I'm messing up all over the place. Okay, 169 is 13 squared. And when we subtract 25, it's 144. Oh, and I like that much better than what I got the first time, because when I take that square root, you know, the square root of 144, it's a whole number, 12. So this side is actually 12. Okay, now we're ready to find the area of this triangular base. 1/2, 12 times 5. And 12 times 5 is 60. Divide that by 2. And we should get that the base area is 30 meters squared. Okay, so we now can start on the volume. 30 is our base. Do we know what the height then is? Now remember, height is the distance from one base to the other. So it doesn't necessarily mean in the picture that you're looking up and down, which is kind of how we think of height, but it's really the distance from that front triangle to that back triangle. So that is our height for this triangular prism. Okay, don't be fooled. Sometimes it goes sideways like that. It can be horizontal. Okay, 30 times 3 is 90 meters. Do you remember what we put there? Cubed. That's right, 90 meters cubed. That's a volume. Okay, I've got 2 for you to try. Again, we've got some different shapes here, so you've got to identify what are the 2 parallel identical shapes. And I'm just going to tell you real quick, this is the formula for a trapezoid. You might need that for one of them. And then the formula for a parallelogram is that one. So I'm going to write here trapezoid and parallelogram. All right, and then I'll let you pause your video and work on the volume of these 2 prisms. Okay, let's see. I feel like that was a challenge. I hope you got that. Base times height. The thing is, I don't know yet what the surface area of the base is. I do see that the base is a trapezoid. I can see it right there, and there's another one on the bottom. So area of that, 1/2 the height times base 1 plus base 2. They did give us all the pieces, so let me plug those in. The height, 1.5. Base 1, doesn't matter if I call that the 3 or the 5, as long as I get them both in there. Let's get a number then. 3 plus 5 is 8 times 1.5 times 1/2. Did you get 6? Okay, the area of that trapezoid is 6 feet squared. Squared's for surface area. Now we know what to put up here. 6 times the height. So the distance between the two bases is 3.5. Let's multiply that. 6 times 3.5. 21 feet cubed. Yeah, volume. Okay. All right, I hope you got that one. Let's try parallelogram. Still, it's base times height. So as long as we know the area of the two matching parallel bases, which I see one right here, it's this parallelogram. There's one, and then the other one is at the other end of it. So we said base times height is the area of a parallelogram. Base right here is 10. And the height, they gave us down at the other end. They told us if we extend that and then draw the perpendicular to it, it's 12. Okay, so sometimes you have to pick pieces out from odd spots, but that is that back parallelogram, which has to be the same as the front one, and its height is 12. So what do we get here? 120 feet squared. And then we're ready to plug that in up here. 120 times, okay, so this is one of those funky ones where the height, and you might have gotten confused by this because we often think of height as going up and down, but height is the distance between the two bases. So really watch for that. The distance between the two bases is 15. 120 times 15. All right, the answer is 1,800 feet cubed. You got it. Okay. All right. We will get to practice those a little bit on the assignment. So there will be some more. On the back, the volume of a cylinder. Or the base of a cylinder is a circle. Okay. Like the prism, except the prisms we were looking at all had polygons for the bases. Cylinder has a circle for the base. So a little bit different. Once we know the area of the circle, we multiply it by the height to find the volume. So it's really the exact same formula that we just did. The base, if you know the area of the base, then you multiply that by the height. So if this is our base, we find that area, which is pi r squared. And then we multiply that by the height to find the total volume. Okay, and I left a little space here in case you wanted to think about the base as pi r squared times the height. Okay, let's try this then. Find the volume of the cylinder round to the nearest 10. Okay, base times height. We need to know what the area of the base is though. Base is a circle, so pi r squared. We're going to find the area of this circle down here, or you could think of it as this circle up here. But one of those, we need to know what the area is. Pi r, they did give us 4. Awesome. Let's put that in. Pi times 4 squared, 50.3. We're going to round. 50.3 centimeters squared. That's surface area of one of those bases. We're ready to put him back in. So 50.3 What's the height? What's the distance between the two bases? Good, I heard you yelling that. I could hear you. 11, 553.3. And it's centimeters, and it's cubed. Yep, volume. Okay, awesome. Let's do one more together. Area of the base times the height, and pi r squared is how you find the area of a circle. So we've got this guy up here. We can look at him. We're going to find his area. Pi times the radius. They didn't tell us the radius. Do you remember how to find that? With a diameter? Yeah, it's exactly half, so 10. Okay, and you might need to make a note somewhere if that's something that you forget sometimes. Write that down on your notes then. 10 pi is 31.4. And, oh, I didn't square it. Oh, man. 31 point, okay. Pi times 10 squared. Oh, isn't that interesting? It's really similar. 314.2 feet squared. Okay, that's the area of the base, 314.2. Now, what's the height? What's the distance between the two bases? 20. 314.2 times 20, the height is 6,284 feet cubed. Awesome. Okay, I got 2 here for you to try. I want you to pause your video, work on those for a minute, and then come back and we'll check. Okay. Area of the base times the height, but what is the area of the base? Pi r squared. Our radius this time is 2. I'm not going to forget to square it this time. Pi times 4 is 12.6 feet squared. And we got to plug that in up here. 12.6 base, and our height is just 1. That's not going to change very much, is it? 12.6 feet cubed. So it went from being 12.6 square feet to 12.6 cubic feet, since there's just a height of 1. That third dimension is just 1. Okay. Then this guy, area of this base is, oh, they gave us a diameter. So we'll cut that in half. See what that is. Pi times 13 squared, 530.9 inches squared. Let's put that in here. 530.9 times the height. So the distance between the bases is 28. And they did that sideways again. So we kind of think that's not a height. Height goes up and down. But really be careful. Height is that distance between the bases. And we should get, oh, it's a big one. 14,865.2 inches cubed for volume. All right, you guys got this. Good luck. I'll see you.